Today we are going to discuss the substitution reactions. We were discussing about the reactions of alkanes. In the previous class, we have done the combustion. And today is the second reaction which alkanes undergo is the substitution reaction. First, you need to understand today we need to understand एक उससे ले लेना substitution reaction. First, we need to understand, bachcho, what is a substitution reaction? If you look at an alkane, first let me explain what is a substitution reaction. If this is an alkane, for example, and these are the hydrogens, so if you replace one of the hydrogen of an alkane, it is known as substitution reaction, right? So any reaction in which one of the hydrogen of alkane, let's say any one, has been replaced like this with any other element, let's say at this moment I call that X. So this hydrogen has been replaced with an element X. So this is known as what? Substitution reaction, right? So please write down the reaction. Please put it away. We can discuss in the end. The reaction in which one of the hydrogens of alkane replaced known as substitution reaction. Any other element, I just supposed at this moment X, Y, Z, A, B, anything, right? So this is known as substitution reaction. So first we need to understand the definition of substitution reaction. And the second step now, how the alkanes undergo substitution and with what. So next line, please write, alkanes undergo substitution reaction when they react with they undergo substitution reaction when they react with chlorine Cl2 gas or bromine Br2 gas in the presence of sunlight.
सर केमिस्ट्री के 3 पेपर होते हैं ना?
Yes.
वो कैलकुलेटर लेकर जाना अलाउड होता है?
Yes.
अच्छा.
So alkanes undergo substitution reaction when they react with chlorine and bromine in the presence of sunlight or ultraviolet light. Now what happens in detail? For example, let's say we have methane. There are 4 hydrogens. It reacts with chlorine Cl2 in the presence of what? Sunlight. or ultraviolet light. So what happens? Please look at this. As I said, one of the hydrogen is replaced. Let's say this hydrogen and this chlorine, they combine to make what? HCl, and the other Cl that will go and take the place of this hydrogen. So what is the product formed then? C, three hydrogens, and the front hydrogen is now replaced by Cl. Okay. Plus, what is the other product formed? Yes, plus hydrogen that came out of it combines with another chlorine to make HCl. Right? So this is known as substitution reaction. I'm just making these square brackets and these boxes just to make you understand, right? So you can simply write like this. Okay, this is a methane. When I react it with chlorine, Cl2 gas, in the presence of sunlight, there is one hydrogen that has been replaced by one of the chlorines plus HCl is formed, right? This compound that is known as methane, and this compound is known as what? Chloromethane. Okay? Either you can write like this, CH4 plus Cl2 gives us what? One hydrogen is less, so it becomes CH3, Cl plus HCl. Okay? Now, one thing more that happens in this reaction, right? Or if I give you one more example in this case, uh, let me ask you, this is ethane, bacho. I mixed it with the chlorine in the presence of sunlight. Can you write the product, please? In the presence of sunlight here.
सर थोड़ा जूम आउट कर लो.
Ethane plus Cl2, what is formed? I know one of the hydrogen is gone, and who takes the place? Cl. So what is the product then? What is this? Cl plus what? HCl. Okay. And the product is known as chloroethane. Even if I give you this compound, here it is a compound, bacho, and here are the hydrogens attached, two hydrogens with every one. And it makes in total C6H12. So I would like you to tell me the product plus Cl2 in the presence of what? Sunlight. Okay, now please write the product. I can tell you the name of the reactant is cyclohexane. All the name is irrelevant for you here. What is the product? Have you drawn? You can replace any one hydrogen with chlorine. So let me replace the one on the top. But आपने जो भी किया है, that's the right answer, okay? So rest are the same: hydrogen, hydrogen, hydrogen. Here is the Cl. Okay? So this is chlorohexane. Chlorocyclohexane, sorry. It's a chlorocyclohexane. Along with what? What is the other product? HCl. Okay, now coming back to the first one again, bacho. If you look at this CH4, please pay attention now. Coming back to the first one, I mean methane. When we react this with Cl2 in the presence of sunlight, now this is an important point which I'm going to tell you right now. One of the hydrogen is replaced and the product form is monochloromethane plus HCl. But this reaction has one other speciality. This reaction is not going to stop here. This reaction continues. This is actually a chain reaction, right? This reaction, I mean methane reacting with chlorine, monochloromethane, is not the product, not the end product. Actually, monochloromethane reacts with another Cl2, right? And this time, one more hydrogen, let's say the hydrogen on the top, goes with the one of the chlorine, और क्या बन जाएगा? HCl, and this product will have two chlorines now, ClCl plus HCl. Yes, what is this now? Dichloromethane. Is this the end product? No. It continues until all the hydrogens are replaced. So one more, C, here is the Cl, here is the Cl, here is the H, here is the H, plus Cl2. So what about this? One more, let's say. So what is the product now? Yes, there is only one chlorine hydrogen left, and this is called trichloromethane. Trichloromethane has a common name as well, and it is known as chloroform. Chloroform. This is a anesthesia. Anesthesia, they used to, for the doctors used to use it, right? So next is there any still hydrogen left? One hydrogen is still there. So it means it will continue to react with another Cl2. And now this time again, this chlorine and this hydrogen, they are going to make what? HCl, and the product is tetrachloromethane plus HCl. So this is known as tetrachloro. Again, this organic compound is again very useful and used as a solvent. It's an organic solvent. जैसे हमारा पानी होता है ना, solvent, we use it for everything. So this is organic solvent, CCl4 tetrachloromethane. Okay. So this is what I said. This is a chain reaction. When it starts, it continues. If it would have been like C2H6, तो फिर क्या होता? All six hydrogens until not replaced, the reaction continues. But one thing which is noticeable here, it's not that all hydrogen go in one step. The number of steps are the same as the number of hydrogens, right? So there is a one hydrogen can replaced in one step, right? So you see there are four hydrogens in methane, so it took four steps to complete. It can't happen in one go, okay? So this is how we represent it in displayed form, but I would like you to understand also in the structural form, right? For example, look at this. If this is CH4, it reacts with Cl2 in the presence of sunlight. What will be the first product, Bacho? 3Cl plus HCl. Monochloromethane reacts again with Cl2. What is the product then? Cl2 plus HCl. Then again CH2Cl2 reacts with Cl2 to make what? CHCl3 plus HCl. And then again CHCl3 plus Cl2 gives us what? CCl4 plus HCl. Got it? So please write their names as well. This is monochloromethane. This is dichloromethane. This is trichloromethane. And this is tetrachloromethane. One last thing which you have to write about this reaction, it also goes same with the bromine, one thing, and then this reaction is also known as photochemical reaction. All those reactions which take sunlight to happen, they are also known as photochemical reactions, right? This reaction is also known as photochemical reaction, right? So that's all about the substitution reaction of alkanes. The third, the next, and the last reaction of alkanes is the cracking. Cracking of alkanes or hydrocarbons. Now, but first you need to understand what is a cracking. Now, what happens? I told you the other day. I'm going to make a supposed data of oil refinery just to make you understand why it is important to have the cracking. Let's say we got crude oil in this Attock oil refinery. And when we did the fractional distillation of crude oil, we have all the fractions which we mentioned yesterday, starting from bitumen and top to the petroleum gases, right? Let's say, just for the sake of argument, you are not supposed to copy this. This is not original data. I'm just, for the sake of argument, going to construct a data. For example, let's say I have, when I did the crude oil fractional distillation, I got petrol that was roughly 20% of the total crude oil which I did the fractional distillation, okay? And then I also got diesel that was also 20%, lubricating oil, let's say 15%, bitumen, let's say 20%, let's say petroleum gases are, for example, 15%. Petroleum gases means the one, and let's say we have kerosene oil. Let's say that's also 5%, okay, or 10%. Now, what is this data? This is how we got the fractional distillation. But you know the market demand? The petrol demand is 46%. The diesel demand is, let's say, 25%. Lubricating demand is 1%. Bitumen demand is 0.5%. Petroleum gases demand is 30%. And the kerosene demand is, let's say, 10%. Now, if you can see, what about the lubricating oil? The one that is needed in the area of the Attock oil refinery is how much? 1%. And how much the lubricant oil they have? 16. The one 15. 14% more. Similarly, the bitumen, what they have? 20%. And what is the demand? So they have a lot of bitumen extra and a lot of lubricating oil. On the other hand, if you look at the petrol demand, diesel demand, what about them? They are less. So what the scientists thought, that the difference between these is only the number of carbons. Like lubricating oil has a 40 carbon attached like this. How many carbons? 40. On the other hand, petrol has 8 carbon attached like this. So they thought if we are being able to cut lubricating oil chain from 5 different places, we would be able to get what? Petrol. So they thought it means the extra lubricating oil, the 14%, we can convert it into what? Petrol, which can meet the demands of the community. This is what they did. So the longer fractions, which containing more carbon atoms like lubricating oil, bitumen, at times the diesel, at times naphtha, they were less useful. As compared to the ones which are lower number of carbons, they were more useful. So they figured out this process of cracking. Cracking means cutting or breaking them, the bigger fraction, into the smaller fractions, which are more used. And this process is known as cracking. So first define what is the cracking. Write down the process. Cracking is the process in which large chain hydrocarbons or alkanes, क्योंकि ये alkenes की भी हो जाती है, so we call hydrocarbons, which are less useful, converted into short chain hydrocarbons, which are more useful. Now the point is how to do it. There are 2 conditions. Please write down. There are 2 conditions of cracking. Number 1, what they do, they took the long chain alkane, heat it to a very high temperature under a high pressure, and they cracked it. So it doesn't have much science behind it. Okay, so write down number 1, high temperature. And high pressure. Okay. Or if they, at times, you know, high pressure is expensive to achieve. So at times they have high temperature and catalyst, which is aluminum oxide and silicon dioxide. So the other way is, if you don't have high pressure, just heat it with the presence of these two catalysts, aluminum oxide and silicon dioxide. Now let's see how the equation goes. Look at this. For example, I have this alkane C6H14. How many carbons? 1, 2, 3, and then 1, 2, 3. If this is an alkane, I'm going to crack. Look at this. So one thing which you have to keep in mind, you can crack it anywhere, right? For example, I'm going to crack it from this point. So how many fragments or the fractions it's going to have? 2. One fragment containing how many carbons? 4. And the other fragment containing how many carbons? 2. I can crack it anywhere, okay, by the way. But at this moment, I'm going to crack it 4 and 2. Now, let me tell you one thing. If an alkane cracks, the product is not alkane only. The product contains the mixture. The mixture of what? Alkane and alkenes both, right? For example, if this is the shorter alkane, the other fragment cannot be could not be the alkanes. The other fragment should be or must be what? Alkene. So it means when C6H14 cracks, what are the two products formed? Let's say if one is C4, so if it is an alkane, how many hydrogens? With 4 carbons, double plus 2, कितने होंगे? 10. Plus C2 वाली alkene है अगर, how many hydrogens? C2H4. So this is how you can crack. Okay, when a long chain alkane cracks, so there is a short alkane with what? Alkene. Okay, so I can put it the other round. Let's say somebody else I asked and they cracked it from here, not from here. So how many fragments now? No. How many fragments now? 2. Each containing how many carbons? 3. So C6H14 cracked to give what? C3. And one of them will be what? Alkane. So C3H. C3H 8 plus C3H what? 6. Even if I asked somebody else and they cracked it from this point. So how many fragments now? Again, how many fragments? 2. Right? And what are these fragments? One of them should be what? Alkane, and one of them should be what? Alkene. Now, which side should be the alkane and which side should be the alkene? One carbon alkene to nahi ho sakta na? So it means the one that fragment has one carbon, that is definitely an alkane. So one of the product is CH4, and what is left? C5H10. But this is not always the case that only 2 fragments are formed. At times, this can break into 3 fragments. For example, here. If it breaks like this, then how many fragments, how many smaller fragments? 1, 2, and then 3. When it breaks down into 3 fragments, keep in mind, one of them will be only alkane. Rest should be the alkenes. One of the hydrogens pure nahi hote. Okay, so one of them should be the alkanes if you don't like balance them out. So if I say it is CH4 plus, if this is alkane, so these two should be what? Alkenes. So one is them is CH4, the other one is what? C2 H4 plus C3H6. Okay, so these two are alkenes, and this is what alkane. At times, this also happens that if I'm cracking C6H14, now please pay attention, and I have got C2H4 and C4H8. Now, can you see both of these products are what? Both of these products are alkenes. There is no alkane. When there is no alkane, then definitely there is another product which is known as hydrogen gas. If you remember, in Haber process, we learned this. That all the hydrogen which is produced in the Haber process, that comes from the cracking of it. So यहाँ जो hydrogen बनती है वो हम फेंकते नहीं है, we send it or we sell it to whom? To the Haber process wale bande ko, right? The one who is making ammonia in his factory, they definitely need the hydrogen gas, so that's why we can sell them. Okay, I'm going to give you one equation. This is your own choice, whatever the products you want to write, but I want you to crack C8H18 and tell me what are the products of this cracking octane. Can you tell me, please? Anyone? Starting from you. C4H10, which is an alkane, and C4H8, so which is an alkene. Excuse me. Just crack it into two parts. That's so simple. Tell me. C2H4, C6H, 12 plus 2. 14. Excuse me, Hassan? Can you? Any two fragments. Excuse me? So, okay, C5H12. It's an alkane. What is the other? Okay. Anyone? Same? Anyone? One more other fragments if somebody has made it. Other than these ones which we already shown. CH4 plus C4H8. C4H8 plus hydrogen. Well done. So this is the cracking. So this is all three reactions of alkane. So listen, everybody, you have to draw this table now at your in your homework. That what we did the reactions of alkane. So please write down. इसको copy करना है पहले. Alkane, and now what you have to do, you have to make a table, type, reagent, condition, and equation. So you have to draw a table like this. Here, under these headings. What type of reactions alkanes had? Number one was what type of reaction? Combustion. Second was substitution, and third was cracking. Okay, and then what was the reagent and condition for the combustion? There was two types: oxygen reagent and condition excess. And there was another one, if you remember, combustion के दो थे, एक और भी था. What was that? Oxygen but limited. Okay, so you have to write the equations for both of them in the next step. Next substitution, what was the reagent? Cl2, and the condition was what? Sunlight. What was the reagent? Either Br2 and sunlight. You have to write one reaction, okay, for each. मीथेन के साथ लिख दें, ईथेन के साथ लिख दें, मीथेन ही रखें सारी equations. Just use the methane. And then cracking. What is the condition? There is no reagent for the cracking, but high temperature and high pressure, or high temperature and catalyst, silicon dioxide and aluminum oxide. Okay, equations वाला मैंने खाली छोड़ दिया. You
सर
have
वो
to
हाई
write
टेम्परेचर पे क्या
equations.
लिखा है आपने?
Okay, इसको डाल देंगे ग्रुप पे प्लीज.
सर वो हाई टेम्परेचर की बात क्या लिखा है आपने?
High temperature, high pressure, and high temperature and catalyst. Thank you very much. That's all from my side.